Hey everyone, welcome back to Mayank Codes. So today is the third episode of our series Bank Financial Transactions Dataset. So just want to get a quick update from you guys. Do I look like Mr. Bean? Because I got that comment from one of my friend after I wore this. Although I have a big nose, but I don't know. So definitely after shaving, I might look like him. So yeah, regardless of that, in today's video, we're going to be talking about the financial transaction dataset finally. In our previous video, we saw the user file and the card file of our dataset. Now we are going to explore the remaining three files, out of which the one file, which is financialtransactions.csv, is my is my main file, having over 1.3 crores transaction. That is 1 crore 33 lakh transaction. It's having a size of 1.2 gigabytes, whereas I also have one other file as fraud labels, which is a JSON file which we will convert into a table. We also have one more file which is again a MCC code. We'll look into that in detail while we talk about the dataset. But what we are going to do in this video, we are going to create a fraud detection system. In simple words, we are going to create a machine learning model which will help me identify whether a transaction is a fraud transaction or not. Now, for this video, I have decided to work on a cloud platform to perform the data analysis on cloud. And for that, we are going to use DataBricks. Now, DataBricks is like you have a computer, but it's online. So you don't have to use your own compute. Although it's not free, but its community version is free, where you can create a single cluster with some 15 GBs of around space or so. I'm not clear with that, but we'll look into that. Apart from that, we are also going to use Apache Spark for the analysis rather than choosing sklearn for the machine learning models or pandas to create a data frame. We'll also see why we are going to use Apache Spark. We have used pandas and polars till now in this series. I am thinking to upload one more video after this for statistical analysis using R. Although I know a lot of you guys are not familiar with R, and basic statistical analysis might feel basic sometime, but it's not. It's very important to understand the structure of the dataset sometimes. But regardless of that, this series is not going to just stay till statistical analysis or basic machine learning models. In the upcoming episodes, we're going to talk about the auto customer segmentation projects as well, where I'm going to build a complete system. And let me give you a quick sneak peek of that, just with the words, of course, because I can't show you the final project yet because it's not completed. So in that project, what I'm going to do is I'm going to put a query which my managers will use. So suppose my manager will use that query to say, hey, we are running an ad. He will write it in the text box that on a website that we will create using Flask. So my manager will write that, hey, we are going to create, we are going to run a campaign to tell everyone that we are giving 5% off to to the hotels. Like every Saturday, if you go to hotel or a restaurant, you will get a 5% additional discount if you pay with our card. And suppose this is the only offer for MasterCard users. So on basis of that, what I'm going to do is it will auto customer segment the data set. It will auto. I will not do anything. I will just make it self-sufficient to do this thing. It's a generative AI project, although, but still we'll figure out everything with the upcoming episodes.
Since in our previous two videos, we have already discussed about users and cards dataset, but still, I assume that you are someone new. And also for my previous users who watched the first two episodes, I want to make sure that they also understand the dataset completely. And for that, we are going to look at our dataset for the final time, but this time we are going to cover up everything to understand the dataset. So I will start by first explaining you what this dataset is having to offer us. You can scroll down and you can see over here. This is a comprehensive financial dataset combines transaction records, the customer information, and the card data from the banking institution. Although this card data is not correct, so don't try to use it. Spanning across the 2010s decade. That means it is 10 years old dataset. And one more thing I want to add on to this dataset is a synthetic dataset. That means it was generated as a fake dataset. We can do that in Python. We can generate fake dataset. Apart from that, we have the dataset is designed for multiple analytical purposes, from synthetic fraud detection to customer behavior analysis and expense forecasting. Since we are already working with the first analysis, which is going to be the fraud detection analysis, so we are going to look into that. And then in the upcoming videos, as I've discussed in the starting of this video, that we are going to make the customer behavior analysis, which is basically customer segmentation, as well as some other projects around it with Gen AI as well. Okay, so let's see the 5 files that we have over here. We have the transaction files. Transactions data.csv is going to have 1.33 lakh transaction. That means not 1.33 lakh, 1 crore 33 lakh transaction. It's like 13 million transaction. Okay, so 13 million is not a small number. We are not going to analyze the complete transactions.csv file because again 1.2 gigabytes of file to analyze will take at least half an hour to run the code. And as I've told you earlier, we are going to use DataBricks for this video. Running this much size of file on the cloud will obviously take more time, and it's not a reliable case for the video. Although we'll understand this file completely, still what we will do is we will segment this file into 4 card types, that is MasterCard, Visa card, MX card, and Discover card. We'll talk about that in this video only, but after some time. For now, let's just look what this file has to offer us. So this is a transactions data file. Over here we have, let me come down. You can see we can select the transactions data.csv, and this file is having the amount, timestamp, and the merchant detail. Now over here, merchant ID is something new. So let me show you. We have a ID, which is a unique ID for each transaction in this dataset. In total, we have 1 crore 33 lakh transaction, or I would say 13 million transaction. So this is a unique ID for all those transactions in my transactions data.csv file. After that, we have date and time of the transaction. As you can see over here, we have the client ID, the client who is doing our transaction. In total, in our dataset, we have 2000 unique clients. So this is the client ID for all those unique users, starting from I guess 0 or 1 to 2000 as a client ID. So our client ID will be between 0 to 2000, or like from 1 to 2000, or 0 to 1999. I'm not sure about it, but yeah, it's we have 2000 unique clients in our dataset. So for each client we have multiple cards. So in total, the number of cards that we have in this dataset, the unique cards, are 6146, and these are my cards ID, which is a unique ID for each card. So in this dataset we have the transaction ID, the date, and the client who is doing the transaction, and the card ID is the card ID from which he is making the transaction. The amount is the amount he is making in the transaction. Then we have this use chip, which is a value to say whether a transaction was a swipe transaction or a chip transaction or an online transaction. So this is again a categorical variable that we have. We have merchant ID, which is for merchants. Now this is again not a unique ID, but still we don't know the merchant ID. Like we just know the merchant ID. We don't know anything else about the merchant. Although we do know the merchant city and merchant state, but apart from that, we don't know anything else. We have zip as well, which is the zip code of the area where the merchant is living. And then we have the other two variables, which is for the error. You don't have to look at this, just ignore the error right now. For the MCC code, now let me explain you what is MCC code. All of the card brands like MasterCard, Visa, MX card, or Discover card, they are having a unique ID for each type of transaction. Suppose you and your friend are going to a restaurant and your friend pays with his card, and you are going to a restaurant. So while that transaction is being stored at the servers of MasterCard, they will assign a unique ID to the business, and that ID is my MCC code. So to all transactions like restaurants, we are assigning a unique value, which is my MCC code, to that kind of transaction. So all kinds of transaction related to restaurants will have a different MCC code. All kinds of transaction related to a car purchasing or a bike purchasing or a vehicle purchasing will have a different MCC code. Suppose you are going to a healthcare service, over there you used your card, so there it will be a different MCC code. So to each industry or to each service that are possibly available right now, we assign a different MCC code to that, just to track what kind of transaction the users are making. And using this MCC code only, in future we are going to perform the customer segmentation so that we can run the campaign only to those potential users who can take the advantage of that campaign and ultimately generate profit for our brand. Okay, so MCC code is really useful. For this dataset, we have only 188 or 189 unique MCC code. That means the transaction is like the all transactions that we have, 1 crore 33 lakh transactions that we have, are done for 188 unique type of businesses, where the merchandise is given, the merchant state and city is given, and the zip code is given as well. Yeah, so this was all about the transactions data. Now let's look at this client ID. Client ID is basically the user's data, where I have ID as my client ID. So let's move on to the users data.csv file. Let me select this. To get all the columns available, you just have to do it. I don't know why they have added it, but maybe for a very large data set where we have thousands of columns, they don't want you to see all the columns and load all the columns. So that's why they have probably done it. Kaggle, that was really a nice job, but still not of our use for the dataset having only 14 columns. Still, let's look at this users data.csv file. This will contain the data about our users. In total, in our dataset, which is my financial transactions dataset, in our bank, we have only 2000 unique users. So this ID will be from 0. Okay, so it's from 0 to 1999. So there is total 2000 unique users. We have the current age of the users, which is not updated. But since this dataset is of like 7 years ago, it was last updated. So we'll consider this current age as the current age only for the analysis purpose. We have retirement age, we have birth year, we have birth month, we have gender, we have address, we have latitude, longitude, value, from which we can calculate the exact location of the user. We have per capita income, which is like a family total income. So suppose, let me explain you what is per capita income. Suppose you are living in your family of 5, so you are only earning, so you have a earning of $1 lakh or 1 lakh rupees or maybe any other currency. So you are living in a family of 5, so your per capita income will not be 1 lakh, it will be $20,000, though your yearly income, which is over here, is going to be equivalent to 1 lakh. So this is what the difference between per capita income and the yearly income, which can be a good predictor for a lot of analysis, which we will consider in the further episodes. We have total death, which is the death taken by our user. We have credit score, which is the credit score of our user, and the number of credit card defines to how many unique cards do my user have. So you also can have more than one cards. So in this dataset also we have 2000 users and they can have multiple cards with them. So now let's talk about cards, because we right now only talked about cards. So you can see this is my client ID and it will work as a foreign key in my transactions dataset. So in my transaction dataset, we have the client ID over here. So foreign key is basically from this client ID, you can access to any detail of the user by coming back to the user's dataset. So let's say for the client ID, here we have 561. So for 561, in this dataset, we can't see what is the current age of this client. But if you go back to the user's dataset, over here, we can see the current age of the client having the ID as 516, although I can't see it over here. But if you scroll down, you'll get the 516 user, or we can just arrange it in this ascending order. Not needed, but still, I just want to show the curious users that I have. I'm not gonna scroll till 500 values, guys, check it by yourself. Okay, so after that, let's talk about the cards dataset. Now this card dataset is also having a unique ID, which is a unique ID for the card, and the client ID, which is my client over here in the user dataset. This is my ID. So this ID and this client ID are basically the same. Here my client ID is working as a foreign key, referring to this user's data table. I hope you know the basics of SQL. If not, understand it in a way that over here I'm not giving all details of user. I'm just giving the user ID of the user. And if you want to check more details about the user, you can basically go to this dataset. And for the specific client ID, you can check the other details. Like for 825, we can see the current age is 53, the retirement age is 66, and so on. So in the cards dataset, we have card brand, card type, which is the debit, credit, or debit prepaid. We have card brands. In total, we have 4 card brands, which is MasterCard, Visa, MX, and Discover. We have unique card number, which is also a unique key because every card is going to have a unique card number. We have expiry date for each card. We have CVV number. Although don't try this, it is not going to work, guys. I've already tried it to check my luck. Okay, just kidding. So this is a synthetic dataset. That's why it will not work. Okay, so it's not a real dataset. We have hash chip value, which is going to tell whether a card is going to have a chip or not. And you can see Kaggle has already created this pie chart showing that almost 89% of our cards are having chip and other 11% are not having chip. We have number of card issued which will say that single card was issued for 2 times or for 1 times or for 3 times. So it's like the same card, how many times the same card was issued to the user. So if the card is expired, we are getting the same card again, or if the card is stolen, we are getting the same card again. So like that, how many cards were issued. So this user got 2 card, some users will get 1 card, some users will get 4 card, depends on the user. You can check the values over here. Then we have the last value as credit limit. Although we missed 3 other values, don't worry, we just have to click on select all. We have the credit limit, which is the credit limit for each card. I hope you know what is credit limit, and if not, then credit limit is the limit of the card. So without paying, you can basically use that limit as your own money. Of course, you have to pay by the end of the month. If you will not, then you will get a heavy interest on that money. So of course, not recommended to those who are not having a stable income. So yeah, then we have the account open date for the user. Last year pin changed as well, and then we have cards on dark web. This last value is always false, since you can see over here. So in our previous video, what we did was we basically just dropped this column because it was always false. Still, it's a good column to analyze, but although it's of no use because all the values are false. After that, let's talk about the 2 new files which we never discussed before, which is train fraud labels.json and mcc codes.json. Now you can see that in the transactions data, we have this mcc code. So I've already told you that each code will be used to basically distinguish a different business. So in total, we have, I don't know how many unique values, but we have around 180 unique values. So MCC code over here defines to a business. So this MCC code.json is a JSON file which contains what kind of a business that MCC code is having. And in total, we have 109 items. Okay, so we have only 109 or 108 unique businesses for the analysis in this data set. So we have only 108 unique MCC codes or 109. We'll check that. So you can see over here for 1711 MCC code, it refers to a business that is related to heating, plumbing, air conditioning, or contractor, like all these contractors. Then for 3000, it's for steelworks. For let's say 3144, it's for floor covering stores. And like that, we have these different unique values. For doctors and physicians, we have 8011. For medical services, we have 8099. And like that, we have unique values over here. For barbers over here, I just saw it right now. Okay, for restaurants, you can see it's 85814, and for barbers I don't see it, although it's gone. I'm not going to waste my time on that. So like that, this file is basically going to have a dictionary kind of structure where we have unique mcc code, and corresponding to that we have the business that is having that mcc code. So this is given by the credit card brands, although in real life I guess that there will be more mcc codes defined by the card brands like MasterCard and Visa. But for this analysis, we are only going to consider this 108 unique MCC codes. And then we have the last file, which is my train fraud labels.json. It's a very big file again, 159.08 MB. Now, let me tell you what this file is going to have. This file will have only 2 values. The first one will be my transaction ID, and the second one will be a label as yes or no. The name itself suggests that it will tell me whether a transaction is a fraud transaction or not. So it will be having a binary value as yes or no. In our real transaction files, we had 13 million values, but over here we are only going to have 8.9 million values. That means we don't know what is going to be the um, values of whether a transaction is fraud or not for the remaining 40 lakh values or 30 lakh values. I guess 40 lakh values, yeah, somewhat around 40 lakh values. We don't know what that transaction is, like it's a fraud transaction or not. But on the other hand, we have 90 lakh values or around 180.89 lakh values, I would say, 8.9 million values. For that, we know that whether that particular transaction ID is a fraud or not. So this is wrong. We have definitely more than 5736 items in this table, in this JSON file, which we will convert into a CSV file just after understanding this file over here. So we can see we have multiple transaction ID over here, along with a label whether the transaction is a fraud transaction or not. So I guess I've took a lot of your time explaining this dataset, but it was really important, guys, because what I feel is once you understand the dataset, you explore it by yourself, you get that view now to analyze it in a way that it makes sense. So that's why in real world also we spend more time understanding the dataset than actually making machine learning models to it. Because once you understand what your dataset has to offer, then and then only you will be able to apply multiple concepts. So after understanding the MCC code, which was for me also something new, because I have never worked in a bank or a card company. So for me, MCC was something new. Like, oh, they are checking what kind of a transaction we are making, so that they can send us the ads on basis of what our transactions look like what our transactions are based on. Like, we are spending more on food, we are spending more on healthcare, so like that they can send us the uh, offers or something like that, which we can take use of, and even they can generate more revenue. So overall, I hope you enjoyed having a look at this complete data set. Although I know I am making the series a little bit boring by doing this thing, but trust me, guys, taking a very basic data set and talking about the DataBricks and Apache Spark will not make a sense. But if we take such huge data set, it will definitely create an impact overall on your resume and on your understanding as well. So now let's basically separate these files and make the files which we can use to create the machine learning model. The very first thing that I can see, what I can just do after clicking next or after stopping this recording and again recording, will be to convert the CSV, or I would say JSON file, which I have over here as MCC codes and train fraud labels, to CSV file, so that we can perform the further analysis. So let's do it. So before we continue to analyze and create our machine learning model on DataBricks, I want to do some filtering on the dataset over here to basically make it smaller. Now, although you can perform the analysis on the whole transaction file, but it is a bit challenging for me since I'm using the community version of DataBricks. I can't analyze such large files with a limited number of time. While I was working on this dataset, I used DataBrick, and at that time it took me around 40 minutes to run the code. I don't want this video to take years to make, and since I'm also going to do some crazy stuff by the end of this video, we are going to do experiment tracking through MLflow. So it is not feasible for me to use the complete transaction files having a total value summing up to almost 90 lakhs for the analysis in the end. And it is very challenging for me to handle this and make video at the same time. So although you can do it on your side, you can try it on your side. You can check it for any other card brand as well. For this video, we are going to make a machine learning model to detect fraud only for the MX card brand. You can do it for Visa, MasterCard, and Discover card as well. You just have to change a single line of code. With that said, let's first convert the JSON files that we had having key value pairs to a CSV file. Okay, so over here in my VS Code, we have created a JSON to CSV notebook. We have created a separate folder as data processing for it. If you want to access this notebook, if you want to access the code, we have earlier performed the statistical analysis as well. If you want to access that code, you can go to my GitHub repo, which I will be sharing in the description. You can use that code as well. Regardless of that, let's continue the discussion of converting a file of type JSON into CSV. For that, we need some dependencies or some libraries which we are going to import. You can say that import JSON and it will import the library. Do the same thing for all other. Now define the path of your JSON file. Over here we have the JSON file in the data. We are putting these two dots because first we want to come out of this folder and then we want to go to the data folder. If we will not put these two dots, it will find the data folder in this particular folder itself, which is data processing, and it will not get it, so it will throw an error. So make sure to first get out of the current directory or the current folder that you have, sorry for this, and then you can go to the new folder that you want to go. Okay, so yeah, it's a basic thing which you should know. Similarly, we'll also give the CSV path which we will make like a CSV file. So that CSV file will be stored as mcccodes.csv in the data folder only. And after that, if we don't have the data folder, we will make sure to create one if we don't have the data folder. So it will only create it if we don't have the one. Okay. So if it is existing already, it will not create a new one, or it will not delete the current one and create a new one. In the data folder, we have other files like cards data.csv. We have the train fraud label.csv, which is not actually given by the Kaggle dataset. It was in the JSON file format, but we converted these two files, which is mcccodes.json and train fraud labels.json, to a CSV format over here. And for that, what we are doing is we are opening the JSON file, and then we are loading the JSON data, and we are basically converting this to a dictionary. And in the end, we are opening this, and again, we are converting the dictionary that we created into the CSV format. Okay, so again, this CSV path refers to the path that we assigned over here. This is an empty file which was created at the beginning of this code, and then we filled this into a write mode, and we gave this field names as MCC code and description. And what we basically did was we took these two values of MCC code and description from the JSON file, and we converted those two values into CSV format. So this file is really small, only having 109 values, so I can show you, but I can't show you this train file, which is my train fraud labels. So when you go to this MCC code right now, it's in the format of JSON. So you can see over here, we have this curly braces, we have the unique ID, which is MCC code and corresponding business to it. There are total 109 unique values over here. So we have all of this. We converted it into a CSV file, and it looks something like this. On the top, we have the headers as MCC code and description. Okay, similar to all other files we had, like cards data. Over here we have these many values, and these are all the fields that we have. Okay, so I hope you understand what we are trying to achieve over here. After this, it will show that we have created the CSV file. I will not go step by step again because you can easily understand this. We have the right headers to get the headers, and then we are going to write the rows in which we will pass the dictionary which we created over here. Okay, having the MCC code as key and description as value. We are going to fetch all the key values from the JSON data.items which we fetch from the JSON files over here. You can look at this code, you can understand it. If you are unable to understand a single line of code, you can either comment in the video for where you are basically stuck in, or the better solution would be to use any kind of chat model to ask him what solutions you can make to solve the error, or if you want to understand what's going in the code, you can do that as well. Code. Okay, so we created the CSV file. We also checked the CSV file. We can also, now it's a CSV file, so we can read this CSV file using pandas. So pandas pd.read CSV, and we are passing the path of this file, and then we are just saying that df. So what df will do, it will show all the values. So in total, it starts from 0 and into the number goes to 108. So we have total values from 0 to 108. Although the unique keys are not from 0 to 108, we have MCC code like 5812, we have MCC code like 5941, and like that we have total 109 unique MCC codes in this CSV file. Similarly, we will do it for the train fraud labels.json file. Will come below. We will assign the path to the JSON file and also to the converted CSV file which we will make. After that, if data doesn't exist, we'll create this repository, not repository, folder. Then we will open this file and we will fetch this JSON file into this JSON.data. We will assign the target data as JSON target. So what is the problem with my train fraud labels is that in the MCC code JSON file, initially we have the key and values. But in this train frauds label, we are not having directly the transaction ID and whether the transaction is fraud or not. Initially, we are having the main key as target, and in the target we have all these transaction ID and whether the transaction is fraud or not. So you can check back to the Kaggle link which I have provided. Over there, you will understand what's the difference between MCC JSON file as well as this fraud labels JSON file. So what I'll do is I'll quickly just fetch this target over here from the JSON file, and in that target I have all the key value pairs which is like my transaction ID and whether the transaction is fraud or not, and I will convert it into a list just like I did before, and then I will assign this as the row headers, and I will pass the rows from the list that I have just recently created. After I do this, it will take some time to run because it's again a big file having almost 90 lakh rows, and the total size is 158 MB, so it will take some time to run. You can use pollers over here on your side to make this a bit faster. Okay, although I didn't use it because it was working well for me, but still pollers is a good option. It will cut off the time by almost 5%. Pollers is really fast. And then if you want to check whether this CSV file is working perfectly, you will create a data frame using pandas for this CSV file. And after using df, we get this whole file as transaction id and fraud label. So in total we have 89 lakhs rows and only 2 columns. I hope you understand this. After this, we have polars as PL, and what we are doing is we are basically uh, importing polars, because now we are going to read the POS file, the daddy file, which is my transactions data. It's of 1.2 gigabytes, so I had to use polars this time. I didn't had any option. So after that, I'm gonna count the unique ID that I have in this dataset, and which says that in total we have 1 crore 33 lakh transactions, a unique transaction, which is like 13 million transactions. A very big number, a very fat number. So yeah, 13 million transactions to work with. I can't do it because DataBricks doesn't offer me this much compute. So in the community version, we get some compute to work with. And so what we are going to do is, first let me explain you what we are going to do. Then we will do the code, because coding is easy. Nowadays, coding doesn't matter. The concept does matter. Okay. So let's understand what we are going to do. I have this transactions fraud label, which will be having a transaction ID and whether that transaction is fraud or not. In total, I only have 90 lakh values, or I would say 8.9 million values. But in my transactions data, I have 13 million transactions, which is equivalent to 1 crore 33 lakh transactions. But I only have the fraud label for 90 lakh values or 8.9 million. What about the remaining 30 or 40 lakh transactions? For that, I don't know whether they are a fraud transaction or not. So if I don't know whether they are a fraud transaction or not, how can I apply machine learning model onto that? Because when you apply any machine learning model, over here we are going to perform classification model, because we want the output as yes or no, whether a transaction is fraud or not. So what we need to at least know for the model which we are creating whether that particular transaction is a fraud transaction or not. Then and then only we can apply a machine learning model to the test, to basically get its performance, analyze the ROC curve, AUC, everything like that. So for that we need to know the fraud label. Since we only have the fraud label for 89 lakh values, I will filter this transactions data to only those values for which I know that the fraud label exists. And I will filter out this transaction dataset with only these values. And I will remove all the transactions which ID, whose ID is not present in my fraud labels dataset. Understand this thing, because see guys, if you will not understand what is going on, you will create this project and ultimately you will be like still a one who doesn't know anything about the project. So yeah, my great English, I know. So yeah, so basically what you need to do is you need to filter out the transactions data that we have with a filter that whether that transaction ID is present in this other CSV file or not. If it presents, that means for that particular transaction, I know that filter, that fraud label exists or not. So fraud label exists. Okay. So only in that condition, I'm going to keep that transaction. Otherwise, I will remove that transaction ID, that whole transaction basically, because that will not be useful for my machine learning model. Okay. That will be not be useful for my machine learning model. And yeah, so that will be my first step. Again, after doing this, I will be still remaining with 89 lakh values. Although it is 25% lesser than or 20% lesser than my initial value, which is a big fat number, 13 million transaction, but still 89 lakh values is still not a small number. So again, I will apply one more filter uh, in the transactions dataset. As we know, we have the card ID. So I will filter out all the cards where the card brand is MX. And now the transactions which initially were around 13 million, which we took to 8.9 million after applying the filter of only choosing those transactions which are available in my fraud labels.csv file, to now with the third filter, to the second filter, which is adding the card brand as a filter. So only those transactions where the card brand was MX. So after that, we get only 5.7 lakh values to work with, which is a reasonable number for the analysis, especially when we are working on cloud platform. So yeah, that's it. So for that, we are going to go to this file over here. We are going to use poolers over here. We are going to first read the transactions dataset. We are going to read the fraud labels.csv file which we just created, although I have not run the code because it will basically just crash this video recording. My computer is not healthy enough to do all this task at the same time. So after that, we are going to apply the join between this fraud labels.csv file data frame, which I have over here as df transaction for the transactions data, and for the fraud transactions CSV file, I have it as df filter transaction. Oh no, I have it as df fraud labels. So I will filter the transaction. So I will create a new data frame as df filter transaction, in which I'm going to select the df transactions, and I'm going to join this with df fraud with a left join on id and the right join on transaction id. So transaction id is a unique id of every transaction which is available in my fraud csv file. Okay, so after applying this join, inner join, basically what will happen is all the transactions which are present in my fraud labels will be only shown in this new data frame, which is my df filtered, along with all other details which we had in the transactions data file, which is like the date of the transaction, the amount of the transactions, which are not something that we had in our fraud labels, because in fraud labels csv file we only have the fraud label and the transaction id corresponding to like a transaction id, and corresponding to that we have a label as fraud label, which can be yes or no. Okay, so after doing this step, we have filtered the value. So now from 13 million, basically I will write over here, from 13 million we cut it down to 8.9 million. Okay, which is again a big fat number. So what we will do is we will import this card data over here and convert it into a data frame using polars this time, because it's much faster than pandas. And since I'm using for this analysis also, like for this conversion also, I'm working with fraud label file which is 153 MB and the transaction files which is again 1.2 gigabytes. I had to use something faster, so that's why we are using polars. So after creating a data frame for the cards csv file, we are combining now, we are basically, now this is my main file df filter transaction. So I'm applying the join with this transaction where my card id is given and the id is given on the right. So after applying the left join, what I will have is all the transactions even if the card data is missing. Oh wait, all the transactions even if the card data is missing. Left join all the transactions, card id. Yeah, okay, so basically all for all of my transactions it will filter out it on the basis of like the card id and the id that we have over here. So let me explain you this. Basically this comment is not perfect, I'll remove it. Yeah, so what we are doing is we are basically, yeah, okay, I got it now. Yeah, so what this code is doing is we are basically combining our filtered transaction, which is 8.9 million um, uh, values, and the cards over here, so df cards. So I'm merging these two tables, and on what condition I'm merging? In my df filter transaction, if you saw the transactions data initially, we discussed about the files previously. Over there we had card id. So on basis of that card id, and in my df cards we have unique id as id, which is my card id again. So on basis of these two rows, so this is basically my primary key. id is my primary key for df cards, which will work as a foreign key having a reference to my df cards. So this is my foreign key, card id, which is in this df filter transaction. So card id is my foreign key for df filter transaction, which refers to the card details which I have in df cards. Okay, so after applying this join, what it is saying is that it will filter out all the, it will basically join these two files, and it will also keep all the transactions where the card id is not defined, although it's not needed, but still it has made sure that if there is some card id which is not present in my cards dataset, then also it will keep it, and it will put all the values as null, like for the card id. Like if I will merge these two tables, what will happen is, if in the card id we have all these details, so now along with the transactions data that we initially had, this all rows will also be, I would say, attached with my data set, which is my transaction data set. And if for some card id, if that card id is not present in my cards data, For that card ID, it will put all these values as none. Okay, so it's a very basic thing. Again, nothing really advanced. And after that, what we are doing is basically we are filtering all the values in our 89 lakhs of rows, like our 8.9 million. Just a second. 8.9 million rows that we have in the DF combined uh, data frame. We are filtering all these values with a condition where card brand is MX. So since I have combined these transaction file and the card file, now I also have card brand in my columns, and I will check whether that card brand is MX or not. So for a particular transaction, if a card brand is not MX, I am not going to consider it, and I'm going to filter this whole with the condition that card brand is MX, and I will store it in this new data frame as DFMX transactions. PL.column basically selects this particular column, and then we are checking whether that column is MX or not. It's a very basic thing. If you want to analyze for MasterCard, so you just have to convert this MX into MasterCard. You can just write MASTERCARD. Similarly, for Visa, you can do it, and so as on for the other two cards that we have. Okay, so which is my Discover. Okay, yeah, not other two, only other one. So yeah, error is gone, and you can see we have filtered all the transactions with the card brand was MX. After that, we can perform this, although it's not needed. So I will remove it because it is basically filtering to all the values that you need. So I don't want like this. I want all the values. I don't want to filter it. So yeah. Oh, just a second, guys. Yeah, I do want to filter it because I don't want the details about my card now. So since this combined transaction will have details of my cards as well, but I don't want it. I just want the format of columns as I initially had in my transactions dataset. So what I will do is I will fetch only the transaction ID, the transaction date, the client ID, the card ID, the amount, the merchant ID, the card brand, also the MCC code as well. So I will write it over here. I forgot the column name, so I will do that as well. I think it was MCC code only. Still, we will check it. And the last one was probably, I don't remember. It was, yeah, we had the fraud label as well. I guess, yeah, that's it. Yeah. So this is the last uh, columns that we have, and we are going to work with this data set. So let me just quickly run this again because we have added MCC code. Previously we forgot about it. Okay, we can't use this right now because we have not added MCC code to this data. Okay, I got it. Because see guys, MCC code can be only added when we have it. Right now we don't have MCC code added to this data frame, so we can't add it. So in future or maybe in the DataBricks itself we will add MCC code. Right now it's not needed. It's fine. So yeah, I just had to press Control Enter. Let's run this file. See, after running this, it will probably freeze my screen. But don't focus on my video, just focus on this. It is taking still a lot of time. It will take around 40 to 30 seconds or something like that. But if you will perform the same using pandas, it will take around 2 minutes or maybe more than that. So that's why polars is fast. And I would recommend you to try with pandas as well, so you understand the power of using polars from the next time in your data analysis project. Okay, so just wait for some time. Maybe in the couple of minutes we'll be having our file ready. Yeah, it's loading, it's loading. Let's wait. I don't know why it's taking more than 50 seconds. Earlier it definitely didn't took this much time. Let's just hope it works because it's been a very long time since I'm recording. Yeah, it crossed the 1 minute mark. Definitely pandas will take more than this because again it's polars is fast. I think because of recording at the same time may. So yeah, as you can see, we have successfully stored the file as mx filtered transactions.csv. Now let's go to DataBricks and set up our cloud over there and do the further analysis over there and start by making our machine learning model. Okay. So this is what the cloud community version of DataBricks look like. So to get to this particular version only, if you simply type DataBricks, you will be redirected to Enterprise Edition where you won't get this functionalities. I want to use the cloud for free, And to do that, make sure that you go to this exact link only, which is community.cloud.databricks.com. And once you go there, you have to either create an account or log into your existing account. I assume that you have not created an account yet, so just click on the sign up button and follow the steps to create your account. As I already have my account, I'm going to pass my mail ID over here, and I will get a verification code which I will get from the link right over here. It's U9Y7PF. So U9Y7PF. Once I pass this verification code, I will get this home page right over here. So the main thing over here is that this is a free version. So you are using DataBricks Community Edition. Upgrade for unlimited clusters and collaboration features. Means on this version right now, I cannot do collaboration or I cannot create multiple clusters. Now we are going to use Apache Spark, and the reason we are going to use PySpark, which is a Python API for Apache Spark, is because we want to understand the power of parallel processing throughout different clusters that we have. But for this video, we are not going to have multiple clusters. We are going to have a single cluster. But still, I want to show you the power of this whole community, whole cloud platform, which is DataBricks. So even when you go to a company or an organization over there, if you get to use it, you would at least know what are the features that the DataBricks provide. And then you will be easily able to connect with the enterprise edition as well, because it's not again that difficult to understand certain new features once you are clear with the basics. So the first thing that this cloud platform offers us is a online computer, you can say. So what happens is, cloud is not like you have everything on the space. It's not like that. Cloud is basically there is a person having a lot of computers just like your computer, and you are paying that person. Let's say I want to pay to use your computer for the next 2 hours virtually through the internet. So he will reserve those particular allocations for you, like memory, RAM, or anything else like storage, or maybe if you want to use some routers, anything that you can do on your own space, on your own setup, you can do the same thing on the cloud. So this Databricks is a cloud platform. It provides us to create a cluster, which is like to create a compute for us, to create in simple words, to create a computer for us. But there are some limitations. As we are using the community edition, you cannot create a cluster for more than 2 hours. You cannot create more than one cluster. And there are some other limitations as well, like you cannot collaborate with others. But still, you will get a good intuition about this overall platform after this video. And you will be ready to go. If someone says you want to work on a enterprise edition with others, it won't be a big challenge for you. With that note said, let's go to this compute right over here. If you see this compute is basically you are creating a computer for you. You can say like that. Compute is like the memory, the resources you are going to create over here. Right now, we don't have any active resource. And on this platform, you can only create a resource for 2 hours. After that, it will automatically terminate. Terminate means now you cannot use that resource. So you have to click over here on create compute. And after you do that, you can see over here, we are getting runtime 12.2, LTS, Scala 2.12, and Spark 3.32. So we are going to use Spark for this video. Spark is basically a open source platform for large data processing or big data processing. And to use Spark in Python, we have got an API, which is PySpark Python API, which allows us to use the functionalities of Spark to perform parallel computing and to handle the big data for analytics and processing. Right now, we are only going to create a single cluster. So using Spark is not going to be that reliable. Still, on industry scale, you will use Spark and it will be reliable because they are going to have multiple clusters for you to use. With that note, just leave everything else as it is. You don't have to click on or change anything. Just read this because it's important to read which Spark version we are using, which Scala version we are using. And yeah, that's it. You just have to create on this compute right over here. Once you do that, you will be headed towards this Mayank Parekh's cluster. And now this cluster will take some time to run. And once it is active, we can create a Jupyter notebook. We can upload our data files to this particular platform and do the further processing. So let's wait. It can take from 5 to 10 minutes depending on the cloud service. So let's wait and see once it is up and actively running. Okay. So now you can see my cluster is active. If I click on this cluster over here, you will see that it is active as I'm getting this green button. I can even terminate this cluster if I want, and I can view the JSON, I can clone the cluster, I can restart the cluster, and I can delete the cluster. So now I will go to this notebooks. Currently, I don't have any notebooks connected to this cluster, but very soon we are going to connect a Python IPYNB notebook to this cluster. For the libraries part, right now I have not installed any libraries. But if you go to this new install, you can see over here, we can assign a path to the library right over here, or we can add a S3 path to the library. We can use this PyPy, which is my Python package to install the library. So if I want to, let's say, install the matplotlib, which we are eventually going to install in this video. So for that, I just have to type matplotlib like this. And as soon as I press enter, it will take some time, but it will install this matplotlib library to this cluster to use in our Python library. Okay, so just wait for some time. Similarly, how you install in your local computer, pip install matplotlib, it is going to do the same thing, but now in your cluster, in your compute, in the cloud. Okay, so wait for some time. It can take up to 1 or 2 minutes, not more than that. Yeah, one more thing I want to add. But before that, you can see over here, it is installed in our local computer, in our cloud computer. So now when you click on this new, you can see over here, we have the notebook, we have the experiments as well. We are going to see this crazy feature as well. But for now, we are going to just add or upload data. So when you click on this, you will be redirected to this page. Either you can pass on your S3, and over here earlier on they provided like the features to add the S3, but now what they are saying is if you want to add S3 bucket, you have to specify everything in the notebook itself. You cannot specify over here. So earlier they provided the feature of specifying right over here, but now if you want to plug in your S3 bucket, you have to just pass on the parameters or the configuration keys in your notebook itself. Right now we are not going to use S3 bucket. We are simply going to just upload the files that we have. So what files we are going to upload? We are going to upload our users data.csv file as it is. We are going to upload our cards data.csv file as it is, and our transactions file, which we filtered only for the MX transaction just before this particular slide. Okay. So I will pass on those files. You'll probably not see my yeah. So you will go to your data directory and just pass on the cards data as well as the user data. Once you are done with this, you can see over here, we are getting it file uploaded to file stores slash table. Make sure that your files are uploaded over here only. And if you want to access it, you have to pass on this path right over here. I'm going to also pass my other file, which is going to be my mxfiltered transactions.csv. We already created it just now, so you have to just pass this. Although this file is having very less number of transactions, to be precise around 5 lakh or 5 lakh 70,000, and still it's almost like 36.7 MB, but still very less than our initial transaction file, which was 1.2 gigabytes. So after doing it, either you can create a notebook right over here, but I've already created. So you just have to click on this and you will also create a notebook. And this is how your workspace will have your notebook. So the first thing that you need to do is you need to connect this notebook to the cluster. You guys have probably already connected it. If not, then you just have to click over here and your recent resource, you just have to connect the notebook with the compute. And now you can see it is connected with the Mayank Parekh's cluster. After this, I want to check what files are available in my database. You will probably initially you will not get this because I created a separate folder as Mayank as well. That's why I got it over here. But if I run this code now and wait for certain seconds, you can see the files that I have in my dataset are mxfiltered transactions.csv, as well as you can see I have this cards data.csv, and then I have this random folder which you will not see, don't worry, and then I have this users data.csv. So these are all the files and folders that are available in my files store. In that also I have another folder as table, and in that tables folder I have all these csv files. So this is the location for our files that we have. Now before we move on and talk about PySpark, we will first take an intuition about why we need to use the PySpark and what are the benefits of using the PySpark. So I will explain you this with a good presentation But before that, let's just understand the flow of what we are going to do in this notebook. We are first going to clean our users and cards dataset. If you have already watched my previous video, you know that there are several values which needs to be cleaned, like our credit limit, our yearly income are not of type integer or float. They are of type string because they have a dollar sign before the numbers. And we have to clean that data in order to process it correctly. After that, we are going to put some merging and feature selection for making our data ready to apply the machine learning model. We are going to apply two machine learning models over here, and we are going to apply two different metrics over here as well. I will explain about that just after some time. But before that, let's first try to understand why do we use Apache Spark or PySpark instead of simple pandas and sklearn. So yeah, this was the best definition I could come up with. PySpark is a Python API for Apache Spark, an open source distributed computing framework designed for big data analytics and processing. It allows developers to interact with Spark using Python, leveraging the Spark's powerful capabilities for large scale data manipulation, transformation, and analysis. We are going to see all these three things, which is data manipulation, transformation, and analysis in this video. Apart from these, the key features that the PySpark provide is scalability and speed. Since now we are not going to run the whole code on a single machine, but we are going to take advantages of running the code across multiple clusters or multiple machines. Ease to use is because PySpark is really easy to understand. We'll see just now how easy it is. It can be a bit overwhelming for some people, but it's completely fine. You just have to spend some time around this code and you will understand all the features that the PySpark has to offer. And then there is a word which is hard for me to read, but I know what it is doing right now. So following are the things that PySpark can do really good at. And we are going to see the first three things in this video, which is data extraction. We are going to extract the data from CSV file. We are going to transform the data and then we are going to load the data to a data frame. Structured data processing. Again, PySpark offers SQL and data frames. Just like Pandas is offering us the data frame feature, PySpark also offers the same feature. We have a MLib library in PySpark which can be used to perform machine learning operations. And regarding other two, real-time analytics and graph processing, we'll see that in the further episodes, but I don't know whether I'm going to make videos for them. But for this video, we are going to cover up the first three things. And to be precise in that also, we are going to talk about classification problem because we are classifying whether a transaction is a fraud transaction or not. With that said, I'm going to clean this and I'm going to come to this file right over here. So guys, as you know, in my users data.csv file, let me show you the file only. In my users data.csv file and cards data.csv file, we have a lot of numerical values. And I want to make sure that those numerical values stays as numeric values. If I go to my users data.csv, you can see my yearly income, for example. Again, I have to select all to see all the features. Okay. So I have to go to this yearly income and you can see this is with a dollar sign. So of course it is not a number, it is a string. Similarly for per capita income also, for the total debt as well. Oh my god, this person has took a big debt. And then we have credit score, which is fine, but still there are three values which I have to convert into numeric type. Similarly in cards data also we have the credit limit which I want to convert to a numeric type. And there are some other things which I want to change or I want to feature engineer over here. So for that, we are going to use Spark. To be precise, in Python, we use API for Spark, which is called as PySpark API, which allows us to use the features of Spark in Python. We are going to say PySpark.sql import Spark session. This is basically like you are creating a Spark session and I'm going to create it very soon. So once you create a Spark session, you can use the functionality of Spark. And once you close the Spark session, you will be no longer be able to use the functionalities of Spark. So it's like you create it and then you also stop it. Okay. So it's not like pandas. Over here, you have to first create the session. So for that, we are going to say PySpark.sql import Spark session and then PySpark.sql.functions. And in that, what I'm going to import is call function to fetch the columns in my CSV file or table or data frame. And then we are going to use regular expression replace, because guys, why we are using regular expression? What is the use of regular expression? It handles the characters, the numbers. In general, you can basically play with your string using regular expression. Okay, and then we are going to use to date, because our date is also of not type date time, it is of type integers, or I would say text. So I want to convert that text or string type into a date time type. And then we have the when function. After that we have the types as well, and we are getting the float type, because I want to set the updated columns, which is my credit limit, yearly income, total debt, or per capita income, to type float. And that's why we are importing that as well. I'm really sorry, I don't know why my nose is suddenly itching. So the very first thing that we are going to do is, uh, just a second, I need to scratch my nose. I don't want to make you feel gross about it. So yeah, it's done. Of course, I didn't use my hand. I have the clothes with me. Don't worry about it. I stay hygienic as possible. So now we have the initialize Spark session. Over here, we are going to initialize the Spark environment. And the way we do this is by creating a instance for the Spark session.builder, and we are passing the app name as data processing, because over here we are going to process the data. You can give any name, it doesn't matter. Either you can create the Spark session, or you can get the existing Spark session if there was some session which I already created in above code. Okay, so I can get it over here, or I can create it over here, and then I will assign the file locations for all three files in the dataset. And where are my files? My files are stored over here: slash file slash table slash mx filtered transaction.csv. Then we have this cards data.csv, and then we have this users data.csv. After doing it, yeah. So as I said, after doing this, we are going to load the dataset from the cloud storage. And once we are done with that, we will convert the data into a data frame. Cards data contains card detail like credit limit and pin change information. So what we are going to do is, we are going to create a data frame as df cards, and we are going to, instead of using pandas, now we are using the Spark over here, spark.read csv. In this we are passing the csv file, and the two other things that we are passing is basically my header and my infer schema. So what is header? Header will basically convert my first row, which was basically the headings for each of my column, into a heading. Otherwise, PySpark will not understand that the first row is heading. So you have to make sure to make the header as true, to tell the PySpark that my first row is containing the heading and not the data. Infer schema. Infer schema will make sure that my PySpark will understand or try to evaluate the data type for individual columns. Otherwise, it will not do it. Okay. Similarly, we are going to create the data frame for our users data. Just like we did for the cards, we are going to say spark.read.csv. We are going to pass the location, file location of our users data. And then we are again going to say header is true and info schema is equals to true. That's great. After that, we have the mx filter transactions from our previous work just before this. I would not say session, but yeah, we saw that. I assume you saw that. So after that, we are going to repeat the same step, and then we will say that header equals to true and info schema is equals to true as well. So now we are going to perform some data processing. So as I've told you, the first thing that we see as a problem is like our numeric values like credit limit, yearly income are of type string, and we have to convert that. But there are some other problems as well. If I go to my dataset again, if I go to this users data.csv file, or I would say cards data.csv file, and I select all of my columns right over here, and I go to my last column, which is card on dark web. Here you can see all of my cards are not on dark web. All values are false or no, and there is no true value. If there is no true value, if my data set is constant, if my column is constant, should I consider it? Well, it will not make any sense. So what I will do is, I will make sure that I drop this column. How do you drop the column? You simply pass dot drop function in pandas. Over here also, we have the beauty of Spark, which allows us to say that df cards equal to df cards dot drop, and I'm dropping this particular column over here. Now, I want to remove the dollar sign. So to clean the credit limit by removing the dollar sign and converting into float, the PySpark offers us a feature which says that df cards. In that, I'm going to say df card dots with column, and I'm going to select my column as credit limit. I'm going to reg replace. I'm going to use this function, and I'm going to pass this column over here. And what I'm going to do is I'm going to replace this particular dollar sign with nothing. Okay. So I hope you understand this. What is going on over here? Inside my reg replace function, I'm first passing this column, which is my credit limit, and then I'm replacing the dollar sign with nothing, and then I'm casting it. Typecasting means converting the data type into float type. So I hope you understand what is going on right over here. And yes, after that you have to come down and you have to basically do the same thing, but this time you have to select the open account date, and you have to convert this to date. So we have imported to date over here. This is the function available in PySpark.sql.functions. And then we are going to select this account open date, and we are going to convert this into month year format. That's it. Now we are going to flag if pin change is due if last change was 7 years ago. Now why I am passing 7 years ago? Because this dataset was last updated 5 years ago. So if I will say that check before 2 years, then you will get all values as no, because this data was updated last 5 years ago. So in order to check whether anyone changed their card in last 2 years, you basically have to add this 5 year gap of data because it's not updated, and then you have to add the 2 years to check whether people are changing their cards in every 2 year, or to check whether is card not is the pin of card not changed in last 2 years. So to do that, we have to take the 7 over here, because the 5 is my not updated value, because in last 5 years this data was not updated. So last updation was before 5 years, so not update. And then I have the plus over here, 2 years, to check whether users are changing their data pin in the last 2 years. And using 2025 as our base context, we are checking that df.with column pin change. And if the pin changed, I'm creating a new column over here, by the way. And the way to do that is pretty simple. You have to just pass the column over here, or the new column name, and we are passing when function over here. When the current year is less than current year minus 7, then I will pass yes, pin was changed. And if this particular thing over here, which is my pin change due, the current year is not greater than this value, which is 7, it will basically pass no, pin was not changed. So it's a very basic function that I have created, a user defined function. You can check it out on your side as well. Easy to understand. Similarly, we are doing the same thing with the df users. In that also, we are using regex replace function to basically remove the dollar sign. Similarly, for the yearly income and for the total debt. I'm also creating a new column just like I created over here as year pin change last, to check whether people are changing their pin in last 2 years or not. And I'm doing the same thing over here. I'm creating a retirement status, as I already have current age and retirement age in my users data. You can see over here I have the current age and the retirement age. So from that I can gain a new variable as retirement status. If the retirement age is more than current age, that means the user is not retired. But if my current age is more than the retirement age, that means the user is already retired. So I'm gonna add this new feature as well. And similarly, we are going to use when function over here. If current age is greater than retirement age, then I'm going to pass retired. Otherwise, I'll pass not retired. Okay. So make sure also over here, pin change due is my new column, and this is already available column. So sorry for my mistake. Pin change due is going to be my new column. So over here, it is going to check whether the last year was less than this year. If yes, then it will pass yes. If this is not true, then it will pass no. I hope you understand. Okay. And after that, we are again, after creating the retirement status, we are doing one more thing. And don't worry, I will put this code in the GitHub link, so it will be easier for you to use it. This code will be available inside the folder. So I have created several folders like statistical analysis. I will create one more folder as DataBricks. Over there, you will find all these things. So then we have this df users and df users.column. I'm creating a new column as age group. In that, I'm going to say that whether current age is less than 30. If that is the case, then user is between the age group of 18 to 30. And again, I'm passing when current age is less than or equal to 45. The user group will be age group will be between 31 to 45. And similarly, I'm doing it for the rest of the values. So what I'm creating is I'm creating a variable as age group, and this is a categorical variable having four values as 18 to 30, 31 to 45, 46 to 60, and then 60 plus. So you can do that. Then we have this calculate debt to income ratio. So guys, suppose a person is having a yearly income of 50,000 US dollars or 50,000 rupees or any other currency type, and he is taking a loan of 5 lakh dollars. So although the income is less and the debt is a lot, so if I try to justify his debt ratio over here, it would be like it would be like he's earning only 50,000 and he's taking a debt of 5 lakh. So it's like almost, I would say, 10 times higher. Okay. So for such users, taking debt is risky. But if there is a user having a yearly income of 5 lakh and he is taking a total debt of 5 lakh, so for him it is not that scary. He can pay off the loan if he doesn't spend for an entire year, or if he tries to save half of his income for 2 years. But for a person having a 50,000 income, it will be really scary. So that is why we have to consider this parameter over here instead of individually considering total debt and yearly income. So that's why we are taking the ratio of total debt and yearly income, and we are storing this particular ratio inside my debt to income ratio, which is a new column that I've created. And yeah, after that, we are again removing the dollar sign from the amount section of our MX transactions. Since in my transactions data.csv file, which we initially used to get this MX transaction file, you can see over here, the amount is of type dollar. So it's of type string. So I also have to make sure that I clean it. And then we are going to show the first five values to show that my data is good. Okay, so we use dot show function and we are passing how many rows do we need to show, and truncate is like we just want to show it in the correct order, like in this order. Don't worry about it, just ignore it. Okay, so by doing this we can check the updated data frames, not CSV file, because we have not uh, basically converted into CSV yet. We are just keeping it as data frames, and then we are going to count the total number of values. For the cards count, it will be 6146 because we already checked it in our previous video. We have 6146 unique card. We have 2000 unique users, so it will be 2000. We have, I don't know, around 5,70,000 or somewhat like that value for the total number of transactions with the card brand MX. We are going to pass this. And if you want to, as I've said start in the starting, that I have to create a Spark session in order to use PySpark, which we created over here as spark session.builder.app name, and then we assigned the app name. If that name was already existing, get it or create using get or create function. But in order to close the Spark session, we have to use it spark.close. Spark session remains active since we keeping the data frames in memory, because I want to use this data frame in my machine learning model which I'm going to create. I will not stop the session right now, but you have to make sure, in order to save your memory and cluster usage, you have to close it using a simple function which is spark.close, which we will do later on. Okay, so let's see the output over here. It's a bit messy to understand, but it's completely fine because we are Ronaldo fan. Very bad joke, I'm really sorry about it. By the way, I'm a fan of Messi. So over here you can see we have the first pre-processed cards data. It's not easy to understand what's going on over here, but let me just show you what's my output is. We have the users data table now, which is having the first five rows. Then we have the MX transaction, which is somewhat easier to understand. We have the fraud label. We have the MCC code over here, which is my merchant unique code assigned by the card brands. Over here it is assigned by my bank, not card brands. Okay, but still card brands usually assign it to track the type of transaction that their users are making. After that, we have this card data frame has 6146 rows. As I've told you, in the bank we have only 616 unique card issued to the user. Now just understand guys, we only have 6146 card. In real life, I would say, I stay in Chicago. Just imagine the number of cards and imagine the number of transactions that happen. So that's why we need to use the not the community edition over there, because even with this simple transaction file having only 80 lakh transaction, to process basically for the machine learning model. And in total also there are only 1 crore 30 lakh or somewhat around 13 million transactions. Still we are not able to do that, and it takes around 30 minutes to process. Just understand the power of big data analysis and PySpark when you work in an organization having billions of transactions every day. So yeah, that's why we are studying Spark instead of Pandas. Then we have 2000 unique users over here. We already know this. We only have 2000 unique client in our bank dataset. We have 5,72,424 unique transactions with MX card. And then we are going to perform the machine learning model on this MX card, and the target variable that we want to predict will be my fraud label. So now let's see how we can apply the machine learning model of classification to this final dataset, which is pre-processed and feature engineered. So let me drink some water and let's start by looking at our machine learning model now. And you should also drink some water because you have done a great job if you're staying till this point of the video. Yeah, so welcome back. Now we will see how to run the code. The most easiest part and the most difficult part of this video. Because once you will understand what we are trying to do, you will understand anything else. For classification, what we are basically doing is on basis of several columns that we have, we will select several columns over here. And on basis of that column, we will try to predict whether the transaction is fraud transaction or not. And it is a very great idea and a very great concept to work with. Although the problem with this dataset is that there are around, I guess, 900 or so, or maybe less than that, transactions only which are actually fraud transaction. Rest all are not fraud. And this is a very general real world scenario. We don't have a lot of fraud transaction. Otherwise, the government will only do something like they will be taking a lot more bigger actions for it. But we are having very limited number of fraud transactions. Out of lakh or 10 lakh transaction, we get around 100 or 200 fraud transactions, or maybe less than that. But still we get the fraud transaction, so we have to make sure that we make a mechanism to consider those fraud transactions. I would love to explain you machine learning models, and maybe I make a separate playlist for that, but if I do that in this video itself, it will take a lot of time. So if you know the basic, I would say just a very basic intuition about machine learning models like logistic regression, you can still be able to grab what is going on in this particular session. If not, then also I will make sure that you understand, but still I would suggest that at least at once go through all the machine learning models like linear regression, logistic regression, then we have the polynomial quadratic equations like quadratic regression kind of thing. Just try to explore a bit on your side, and I may start a separate series for machine learning. Depending on how many views I get on this series, I will decide it. Otherwise, I will continue this series first and then I will probably make in future. So yeah, for that time, I assume that you already know some basics of machine learning. You at least know what is classification. That is also fine. So for classification, we are using the logistic regression over here. And as I've told you, in the Spark, we get the ML library to work with the machine learning models. Unlike we use sklearn in our traditional Python notebooks, we are going to use the PySpark only to get the machine learning models. We'll start by importing the functions which are columns and UDF. UDF, my user defined function, which we will see in use just after some time. Then we have the features, and over here from the features we are importing the string indexer, which will convert the string into a numeric index. So suppose you have a column having value as gender and male. What string indexer will do is it will convert the whole column from gender to male to 0 to 1. So for 0 it's male, for 1 it's female. So just a simple technique which we use as we cannot work with text when we process the data, and we have to take some numeric values, and so we use this very clever technique of converting the categorical variables to a numeric variables. We have vector assembler, which is basically going to combine several columns into a one single vector. So instead of now taking 100 columns into consideration, we are only taking one single column having 100 values. Okay, so we'll see in that also into the action. And then we have the standard scaler. What it will do is it will convert the whole data frame that we have into a zero mean value and a unit variance. That means your data set will be between -1 to 1. That whole frame will be between -1 to 1. And we will see that also in detail. And you can also, if you can see that I've opened a Grok chatbot over here, which we will use to understand the whole code. Because for me to explain, I might miss something, or for me to explain, I might not know something. That's why using a model is not a shame in 2025 at least. So scalar will basically make the mean 0 and make the variance unit. Okay, unit means 1. Then we are going to use the ml.classification library and we are going to install the logistic regression. Then we are going to use the evaluation function or library, and from that we are going to use this binary classification evaluator function. We are going to import the pipeline and we are going to import the float types over here from the types, and we are going to import the matplotlib. So initially I told you guys that in my compute, if you will go, you will see that we have installed the matplotlib over here. If you will not install it, it will not work. Coming back to my file right over here, it will take some time to load. Probably my 2 hours are going to end pretty soon, so I have to create the cluster again, but that's not an issue. This notebook will still be saved. Okay, so you can connect the notebook with the new cluster that you create if you fell into this issue. So yeah, we process the data and now we are at this moment where we apply the machine learning model and we are talking about this matplotlib. So we also installed it. Now we will understand each code line by line and we will take the help of Grok to understand it. The first code over here says that we have created a function as get class 1 prob and we are returning the floating value of prob1. And over here we are defining a user defined function as get class 1 prob and we are assigning as a float type. And this is my function, which is get class 1 prob UDF. Okay, so I've created a user defined function which is like something like this, and let's see what this function is going to do. So over here, first is my user defined function which I have created over here. So what this is going to do is basically the model outputs a probability vector. This will be creating a probability vector of chances of not fraud or a fraud. Suppose you pass a value to it, so it will give a probability vector that there are, let's say, 0.8% chances of it to be not fraud and 0.2% of chances of it to be a fraud. So where 0.8 is the chances of not fraud and 0.2 is the chances of fraud, that is class 1. And since this function extract the fraud probability, we are only going to talk about the index 1 over here. So we are only going to talk about the chances of it to be a fraud. Okay, so class 1, not class 0. Because for a class 0, we don't care that it's a not fraud transaction. What we worry about is that whether it is a fraud transaction. So understand that just I'm giving a quick kind of intuition of what we care about. Suppose you are making a machine learning model to predict the cancer or the chances of cancer. So what do you want to predict? Whether that person will get a cancer, so this should be more accurate, or whether a person is not having a cancer, this should be more accurate. Think again, you want to make a machine learning model and you want to check whether a person is having a cancer or not. So where should I get more accuracy? Whether that person is having a cancer in that particular domain or whether that person is not having a cancer. Well, if I try to predict wrong values for a person not having a cancer, it's fine. But if a person is having a cancer and I predict that thing wrong, then it's a thing to concern about. And we'll talk about that using false negatives, true positives in our classification table that we create. Confusion matrix. But for now, we are not going to look into that. We are just going to look into our user defined function. So it will basically extract the fraud probability. We will use this in our ROC curve, uh, which is a curve that we make to basically get the area under the curve, which will be helpful for us to basically find out the accuracy for this particular model, which needs the probability of the fraud. Okay, so although these functionalities are not really great to understand. Still, like, you don't have to understand this code. You can basically use this overall in all kinds of models, but still you should get an intuition what we are trying to do. Registers the function so PySpark can apply it to every row in the data frame. So we are basically registering this function and later on we are going to use it. That's great. Now let's see what we are doing over here. We are basically converting our data frames, which I created in this right over here. Cards, not cards count, DF cards, DF users, and DF MX transaction. So since I have not closed this Spark session, I can use this data frame in my different cell over here. So I'm going to convert this data frame as users, cards, and as MX. So what I'm doing over here is that I'm creating a new data frame where I'm joining my transactions and cards. So how can I join my transactions and card? In my transactions file, which is MX filter transaction file, I have the card ID, and on that I can apply the join. So I hope you know the basic SQL joins. Over here, the MX will be having this card ID, and the card will be having its unique ID, which is also going to be a primary key as ID. And on that, I'm applying left join. So all the values inside this will be there. And apart from that, I will also get all the values inside my cards as well. If there is a value or a card ID present in the MX, which is not present in the cards ID, although this is not going to be a case, still if that happens, for all the remaining rows that I have in the card ID, it will assign those rows as null. If you are still not able to understand it, make sure that you understand the basic SQL, although it's of no use once you understand the lines that I'm trying to say, because we will make a SQL query generator as well in the upcoming videos, so that our business analyst or our end user manager or someone else can perform the queries or ask questions regarding our dataset and get the answers of those questions rather than being depending on a person to answer the questions. Now we are also going to select some particular columns over here from the transactions ID, which is my ID of transaction, client ID, amount, fraud label, which is going to be yes or no value, and MCC code, which is again industry code that is assigned by the card brand, or over here our bank is assigning it. It's a unique ID for different kinds of businesses to whom my client is going to pay. Then we are going to add the user's data to this new data frame, which is df temp, which is my temporary data frame. So I'm going to create a new data frame over here as combined data frame, and in this what I'm going to do is I'm going to put a join between client ID and user ID, and I'm going to again put a left join just like I did over here. This time I'm going to select transaction ID, client ID, amount, fraud label, and all other remaining variables of our interest for this particular analysis. Then I come down over here, and what I see right now as a fault or something like that, I can say is I can add more columns to this. But since I've already added the columns right over here, I don't need to do it, but I can do it. So yeah, we have this. Right now we only have this many sets of column. From the cards data, I can also add I can do it over here. From the cards data, just like I did over here, I've got the user's detail. I can get the detail of the credit limit as well. So here I can pass the credit limit as well, because credit limit can also be a factor of our interest over here. We have also not added pin change due and other variables, as you can see over here. But let's just not take this thing right now, but we can. And your homework is to basically take these values as well. I have left it for you. Make sure you take those columns over here. Or let me just take this credit limit, and for all other columns, I leave it on you. So just like I have take this value over here for the card, which is my credit limit. Now this credit limit will be stored in my DF temp. So over here, what I'm going to do is I'm going to also add this new column, which I fetched credit limit into my DF combined data frame as well. It's not really hard to understand, guys. Still, I know sometimes it get a real bit overwhelming when you see such a large number of lines of code. But yeah, that's what I have done over here. I have basically applied the joins over here, and in the end I get this new data frame with only these many values, this many values. And yeah, after that I can also get this value over here, which is my credit limit. And yeah, that's it. uh, you are basically assigning the list over here with the categorical columns. Since my MCC code is having only 108 values and it's a categorical column over here, gender is going to be a categorical column, retirement age is going to be a categorical column, whereas my amount, current age, per capita income, and all other variables are of type numeric, so those are my numeric columns. So as said before, for our categorical columns, we are converting those columns into numeric type. Coming back to this explanation code, we have already applied the joins on the data frames, so we'll not look that again. This is my categorical column and this is my numerical column. We already saw that over here. We have done that. We have defined our features basically, which we are going to use to analyze. Although we can analyze more features from cards table, which we have not added, like pin change due, which was yes no value, whether the pin is changed in last 2 years or not. Although we have kept it as 7 because this data was last updated 5 years ago. So in total, we are checking whether the card was updated, pin was changed in last 7 years. But in general, we are basically trying to calculate whether the card pin was changed in last 2 years. We have not taken that variable over here. We could have taken, yeah, we could have taken that, but we are not gonna worry about it for now. You can do it on your side. Although you can see one thing, it is terminated now. So yeah, you will also face this kind of issues. All you need to do is you need to go to this compute over here and you have to delete it. You can't reuse it. You have to delete it. You have to create a new compute over here and just click create compute. It will take from 1 to 2 minutes to 5 minutes to 10 minutes as well to do it. Regardless of that, we will come back to our workspace, and don't worry, your data will be also stored in this. You don't have to again upload your data. It will be stored in the file stores slash tables folder. Uh, but it is not connected, so you can't basically run your code now. So we'll wait for some time. We will first assure that we are connecting with this new cluster. We'll confirm it. Although it says that it is now starting, it is not active yet, but we will wait for it to start. And make sure that you also have to rerun your cell in order to rerun the Spark session, because we now don't have anything on the new computer that we are creating, so we have to run the above code as well. Regardless of that, we will look in the below code, and yeah, the notebook is still working fine. We have assigned our categorical and numerical columns. Now we will see what my indexer is going to do. So basically, as I've told you earlier also, we have the categorical columns as string, but our computer or our model will not understand the strings. So what we will do is, suppose we have 5 rows over here, five columns over here, not 5 columns, what I'm saying. Suppose we have 5 categories over here as, for card brand, we had 4 categories as MX, Discover, MasterCard, and Visa. So instead of naming that as MX, MasterCard, or Visa, or Discover, I'm going to name that as 01234. And yeah, that's it. Suppose we have a categorical column as gender. Over there, we only have 2 values. So we can apply the binary encoder to binary indexer to basically get the values as 0 and 1. We can do the same thing for MCC code, but over here we will have the values from 0 to 108, because in total we have 109 unique MCC codes. And like that, for retirement status, we are only going to consider 2 values, which is 0 for retired or 1 for not retired. And yeah, that's it. For the numerical columns, you don't have to do anything. We'll keep it as it is. Now let's see the code. Over here, we are basically creating the indexer. In string indexer, we are passing the input column as column. So this will be my column. Output column will be as column as well. And since we are taking the categorical columns over here, we are basically passing each categorical column using this for loop. So what this for loop will do is it will fetch the column, which is in the categorical column, initial column will be MCC. So what it will do is it will fetch the MCC, pass that MCC as input column. Output column will be column, that is MCC plus I will pass as index. So the new value for my output column will be MCC slash index, and it will contain the value 0 and 1, not 0 and 1, from 0 to 108, because in total we have 109 unique categories over here. Similarly for gender, this for loop will work, and now my columns will fetch gender over here, which is my second value, and over here the gender will be assigned to input column. Output column will be my gender plus index, which will be named as gender slash index. Okay, not slash, underscore index. So gender underscore index will be having the value as 0 and 1 assigned for male and female. Similarly for my last value over here, which is retirement status, this column will be fetched and passed to the input column, and the string indexer will again do its magic and convert the string into numeric values, and the output column will be of name as retirement status with a underscore, and then again underscore index. That's it. After that, what I'm going to do is, just like I did it for my features over here, my output column, which is my I would say the column which I'm going to predict fraud labels. Fraud labels are also of type string. So I also have to make sure that I convert those into numeric values as well. So I will create a fraud indexer over here, and I will say that string indexer input column will be my fraud label, output column will be my label, and I will keep handle invalid keep. So if there is something which is invalid, a character which is invalid, so it will also handle it. Don't worry about it. Keep it like handle invalid equal to keep. And yeah, voila, that's it. It's done. You have indexed your columns, your numeric columns, your string columns into numeric. Okay, so basically your categorical columns are of type numeric now, so you can analyze. And that is what said over here. Suppose you have male, so it will convert it to 0. If female, it will convert into 1. Similarly for my fraud indexer, the fraud label will be yes or no, it becomes 0 or 1, which is my target variable of interest. So fraud label is my target variable, as I'm going to predict fraud label. Handle keep, if there is unknown data, it will assign a special number instead of crashing. Okay, so yeah. Adding weights. So now this is a machine learning concept. Still, I will explain it because it's really important. In the starting, I said my data is not distributed equally, because how distributed equally? My fraud labels are not distributed equally, because in real life it's not like out of all transactions 50% transactions are fraud and 50% are not. If that would be the case, no one will use the online transaction. So there is a very limited number of transactions which are actually fraud in real world scenario as well, and in our data set also we see the same thing. So when our machine learning model analyze the data, it will focus on both of the things, which is my not fraud transaction and fraud transaction. But since I will be having more transactions with a label of not fraud, it will try to focus more on those values than on the actual fraud values. So I have to make sure that my model panelizes the transaction, or give more importance to the transactions that are having the label as fraud, which is yes value. So for that, we will give more weight to those transactions. How do we do it? It's a very clever maths only. Let me first show you. Over here we are basically doing this. Okay. Now first thing is that we are label counting. Over here we are counting the fraud labels, and then we are counting the total number of transactions that we have. So coming back to the code over here, you can see fraud is rare. If 99% of transactions are not fraud, the model might guess non-fraud transaction every time, which is simple to understand. Assign weight. Rare classes like fraud get higher weight to make them more important. So what we are trying to do is count how many times fraud label appears. So basically we are going to count how many times our fraud labels, which is my yes or no, are appearing. Suppose my yes is appearing for 20 times and my no is appearing for remaining 80 times. Okay. So what I'm going to do is my weight will be the total number of rows. Let's say for fraud transaction, it is 20, divide by count of class. Okay. So it's like fraud are very few, gets a big weight. Okay, so suppose my total number of rows are my total number of transactions. Okay, and count of class is like the count of how many times I'm getting the transaction as fraud out of the total number of rows. Suppose in 5 lakh rows, I only have 100 transactions as fraud transaction. So if I divide the 5 lakh by 100, I will get a number like 5,000. But for the transactions where I don't have the transaction as fraud, the fraud label is basically no, or I don't have this transaction is not fraud. Okay, so for that particular case, the count of class will be more. I will be having more of such transactions. So out of assuming that we have only 100 transactions which are of fraud, so for the total number of transactions which will be 5 lakh, I will be having the remaining 4 lakh 99,900 value as fraud or not fraud. Okay, so when you divide it, you will get a very smaller value for the weight. So for the for the category that is coming for less time, I will get a more weight, and for the category which is getting more time, I'm getting less weight. Am I correct? Yeah, I'm correct. So even if you are not able to understand this, I would suggest you to please pause it for a while and try to understand it. So what we are doing over here is that we are basically assigning a new column as weight to my df combined data frame, and this weight will have the value as total number of columns in total which I got from here. It will be 5,77,000 or somewhat like that values. So that value, so that is my total number of transactions that I have in my df combined, so the total number of rows that I have in df combined. And I will create a new column as weight, and this weight will be having a value as total number of transactions divided by call count. So call count is how many times I'm getting the value as no, whether the transaction was fraud or not. And then I'm going to select the fraud label, and then I'm going to assign the column as weight over here. So what this whole thing is going to do, it will assign two weights over here. First weight will be for transactions which are not fraud, which is going to be really, really small. And other weight, which is going to be really, really big, will be assigned only for those transactions which are fraud. And by doing that, I'm going to penalize the transactions which are fraud more than the transactions which are not fraud. Okay, so watch it for a while, you'll understand it. That's what I can say right now. So this is my label weight. So I'm going to add this label weight over here, which I created right over here. And in that, I'm going to also add the fraud label, which is my fraud label. And I'm going to basically join this with the left. Okay. So after doing it in my df combine, I'm basically combining a new column, which is going to be label weights. So over here in the label weights data frame, we are creating this with two values. So the first column will be my weight, second column will be my fraud label. So for yes, what is the weight? For no, what is the weight? And then I'm combining this with my data combined. So basically this is my data frame, and I'm combining these this particular I would say data frame on the condition of fraud label, because we have fraud label in our label weights as well, and we have the fraud label in our df combined as well, and I'm combining it with the left join. So yeah, that's how I will combine the weights with the df combined file. So how this file will look, so let me explain that as well. So in the end, what this file will look, I will have all the df combined rows, I will have fraud label which will be yes or no, and then I will be have weight. I hope the spelling of weight is correct, and yeah, indeed it is correct. So I will be having different values for credit limit, yearly income, everything like that. And for the fraud label, I will be having, let's say, no. Similarly, for the fraud label, I can have yes. So for the yes, if the transaction is fraud, I will have a big number, a big fat number for weight. But for the no values, I will be only having a very small number like 1.2 or something like that. So now you understood. I hope you understood the use of weight and why do we use it. Okay, and that's how the final file will look like, or the final data frame will look like. After that, we are using the assemble the and scale the features. So yeah, What I'm going to do is I'm going to assemble, basically create a new data frame as assembler inputs, in which I'm going to pass the column and index from the categorical columns, and along with that I'm also going to select my numerical columns. So it's nothing, guys. Remember earlier we used string indexer in our code right over here, and we assigned the new column name as column name slash index. So MCC will be converted into MCC index, but the values, instead of 1, 2, 3, I don't remember what were the values for MCC code. It was not like, it was 4-digit values, 4-digit unique values for each MCC code, but now it will be like 0, 1, 2, 3, and so on. Similarly, for our gender, it will be 0 and 1. Not for gender, but for genders underscore index, the values will be 0 and 1. Similarly, for retirement status underscore index, the value will be 0 and 1. So what I'm doing is I'm basically getting those columns. So again, we are doing it. And then we are also adding those columns with the numerical columns. And all these columns are now stored in this new data frame, which is my assembler input. And what my assembler is going to do is, it's a vector assembler. It will pass this assembler input in the input columns, and the output column will be my row feature. So what I'm doing is I'm basically creating a assembler, a vector over here. And what this vector will do is it will basically convert my 7 or 8 columns into one single column of interest. So after that, I'm going to apply this standard scaler over here. The standard scaler will convert my values and will convert those values between -1 and 1, so that the mean will be 0 and the variance will be 1. Let me explain you what we are doing over here. See, vector assembler over here will combine all the features, example MCC index amount, which we had in the transactions initially, into one column as raw features. So it is creating a new column as raw features, which will be a vector like 1, 2, 100. Like why 1, 2? Because for all the all the categorical variable, I got the numeric values, and let's say 500 for the yearly income, 45 for the total death, and like that, all of my column values will be combined into a single vector like this, which will be assigned the name as raw features. So now I only have one column, which is raw features, which will be having the values as the whole values, 1 comma 500 comma 45, and all other values that I have. Like for all columns, it will be combined into one. Like for all column values, it will be combined into one. And this is what we know. This is what we call it as vector assembler to do this thing. After getting this raw feature, I will be passing this feature into standard scaler as input column. The output column will be my features. I will put with standard true, with mean true. So what this standard scaler is going to do is pretty interesting. It will basically convert the whole thing with mean as 0. That means the center data will be 0 and standard as 1. So scales it to big number. Example, income does not dominate small ones. So we'll get a new output as features. So this will be my final, I would say, data, which I will be using with my machine learning model, which I call as the detective to predict a fraud transaction. So over here we are going to use a logistic regression. Logistic regression is a classification model where we are trying to predict the classes as yes or no. Okay, a binary classification model. So in the logistic regression, you can see, I can show you the code again over here as well. You can see we are passing the feature columns as features, which we fetched from here after applying the standard scaler. The label columns will have the label, and I guess we assigned the label over here. Yeah, this is my output label, which is again string indexed using string indexer, and we have string indexed our fraud label file, which is now as label. So we are passing that as well, and this will be having a value of 0 and 1. And then we have the raw prediction column, which is going to be my predictions. So, oh no, sorry. So then we have the weight column. Okay, so as I've told you earlier also, we are going to assign the weight. So where we created the weight column, we created it over here. So this is my output weight column. Okay, so for yes, the weight will be slightly higher. I mean very higher, because our dataset is almost like all values are all transactions are not fraud, and there are only very few transactions of type fraud. Then we have the max iterator. Again, these are the parameters that we use. Then we have reg param, which is 0.01. And after creating this logistic regression model, we are going to create a pipeline to stage all of our uh, above task, which is fraud indexer, assembler, scaler, and then we have LR, which is this one. So what it will do is this pipeline will basically first initiate this step, and then we are going to initiate the assembler, then the scaler, and then the LR. So that's why we have assigned it like this. So this pipeline will execute all of this step by step. Okay, we are going to divide our data into train and test, because see guys, if you make a machine learning model fully on your test data, fully on your data, how will you test its predictability? Like if you give whole data to it, how will you know how effective that data is? So we will divide our data into 80-20%. Suppose out of 5 lakh values, 80% would be around 44 lakh values, and the remaining 1 lakh values will be my 20% of the data that I will keep as it is to analyze or to test the model's performance. So I will split the data into train data and test data. And for that, we have the random split function in the Spark. And I want to split it with the 80-20 ratio. And this seed over here is basically really useful, guys, because after putting this seed as a random number, it can be anything. It can be this number as well. It can be what it was, like 24. So on basis of that, what will happen is 42. On basis of that, what will happen is even if you try to run this code and it's a random split, still with as you are going to put this seed as 42, you will get the same output as I am getting. Okay, so that's why we use this seed over here as 42. Otherwise, you will get a random answer because you are going to randomly split the data. So you might get a different model performance and I might get a different model performance. So to make sure that the model is reliable across everyone's perspective, we are using the seed over here. Then we are going to fit this data into this pipeline, which is my trained data. I will be making the model, and then we are going to transform the predictions for the test data. So since we want to analyze the performance of this model, we are going to check it for the test data. We are going to use the binary classification evaluator, and we are going to pass the label over here and the predictions over here as well. The predictions which we are getting from here, model.transform test data. Okay. After that, we are going to name this metric as area under curve or ROC, and I'm going to basically get the AUC over here, which is evaluator.evaluate, and then I'm passing the predictions which I got from here. So AUC will be my area under curve. ROC is again a metric that we use to analyze the model's performance. To make the ROC, you can get the AUC value over here, area under the curve over here, and yeah, area under the curve will help us analyze the model's performance. But there is also one more thing called as confusion matrix. So what confusion matrix will tell us is how our model is good at performing the analysis, which is like how it performs to analyze the fraud transaction, how much good it performs to analyze the not fraud transactions. So over here, we are going to talk about true negatives, false positives, false negative, and true positive. Right now, I know you might not know what is of confusion matrix, although this is a part of machine learning. Still, I will explain you. Coming back to the code, we created a pipeline. We performed we made the machine learning model, and now we are basically doing the predictions on the machine learning model that we made, that we named as model. We evaluated the model and we stored the value of area under the curve, and we applied the model to the test data to check its performance. So here the area under the curve, the AUC and the ROC are for the test data only. So to check the performance, you can't check it on your trained data. Trained data is already performing well. So the best way to check for the performance is to check for something that is not given to the model, to our machine learning model. And since we only gave the train data to our model right over here, you can see we are going to pass the train test data to check for the performance. Okay, so the confusion matrix, as I was saying, is made for the test data. So confusion matrix will be created. I will not tell you the steps because it's just a simple code. You don't have to do this, to be honest, but still in Spark you have to. In this we get true negative. What is true negative? True negative is non-fraud predicted correctly. So negative is for the fraud. Okay, so I correctly predicted not fraud, so that is true negative. I correctly predicted the fraud, which is true positive. Okay, fraud caught. I correctly, or I would say if false, I was not able to correctly predict the fraud transaction. Okay, not fraud predicted as fraud. So I was not able to correctly predict the fraud transaction. Similarly, false negative will be I missed the fraud transaction. I I tried to predict fraud transaction as not fraud. I know this is something like even after reading, I was not able to understand initially. So what I will tell you is give some time to this 4 lines as it is really confusing to understand. Right now also after making I would say almost 5 to 10 projects and helping my other friends as well around the logistic regression projects this quarter. He was in a different department, although he was in auditing department, but still he got a logistic regression model to work on a data set. So for that also I explained him what is confusion matrix, and that's why this matrix got a name as confusion, because it is really confusing to understand it. But give some time and you will understand this 4 values over here. And what we care about over here is that what is my model's efficiency in predicting the fraud labels. So this will be my confusion matrix that I make over here using by calculating these 4 variables over here. You can try it by your side. I will not force you. But what it is trying to do is it is calculating basically whether the row was labeled as false, means the transaction was not fraud, and it predicted whether the transaction was not fraud. That means it's a true negative. If the transaction was not fraud and the prediction was transaction was a fraud, then it's a false positive. If it predicts if it predicts the transaction as not fraud but it was indeed fraud, then it's false negative. And ultimately in last we have true positive when the transaction was fraud and it predicted it as fraud, and then we get this confusion matrix. I know it's a bit confusing, but give your time, it is not that confusing as well, you can understand it. Now for plotting the ROC curve again, we don't need to do it because this is something like you just have to read the code and understand what is going step by step. But it is not necessary as well at the same time, because nowadays most of the libraries do it for you. So although I have kept the code for you to understand, but still it's not necessary. Basically what I'm doing on the step 10 is I'm creating the ROC curve over here using matplotlib. So since my new cluster is created, I'll make sure that I install the matplotlib over here in this cluster as well, since you can see it is not installed yet. So what I will do is I'll go to my PyPy library, PyPy over here, and I will type matplotlib exactly as it is. You can also assign the specific version with equal to, but I don't want to do it. So I've named the library that I want to use and I've put it over here, which is matplotlib. Wait for some seconds or maybe a minute and it will be installed, as it is not a very big library to deal with. It's installed, and now we'll go back to our notebook over here and make sure that this notebook is connected with the server. Since this is a new cluster, I will again rerun the code over here for the pre-processing to initiate my Spark session and all those data frames that I created and used in my machine learning model. So I use the DF users, I use the DFMX transactions over here. You can see I've used these 3 data frames in the machine learning model as well. So I'll wait for some time till it processes all these data frames to get the columns ready for the analysis. Like what we are doing over here, we are removing the dollar sign and we already talked about it. So just wait for a couple of seconds or minutes and it will be executed. After that, if we will run this code, since we understood each line of code, in the end we are basically using the matplotlib, and in this we are plotting everything. We are putting it as false positive rate. What is false positive? False positive is when the label was not a fraud, but it predicted it as a fraud. And then we have the other thing on the Y as true positive rate, which is when the label was fraud and it predicted the fraud. Okay. So now take the name of the gods you believe in and run the code. It will take some time, but yeah, it should definitely get the error, and it got it. So I believe this error is because I have not put it as cards over here. It should be cards, not card. Okay, just a very small error. Still, hopes are high, and let me just fly. I don't know what I'm making right now, but yeah, my English is great. I have a great poetry skills as well, thanks to ChatGPT. Again, wait for some seconds to let the model run, and let me just show you what it is doing over here. Spark jobs. So it is dividing this whole task into jobs, and it is doing it. It will take some time. Wait for that. Let the model run. So yeah, it will take around 2 to 3 minutes, possibly. Till that time, let's analyze our next file, which is also a machine learning model, doing the same thing, nothing different. But the only tweaking that I've done over here is that instead of making the seed as 42, which I did above, now I have made the seed as 24. And by doing this simple thing, I got a different answer. We'll look into that. But first, let's wait for this code to run. So let's see. And with this single change in the below model, by just changing this seed to 24, I am creating a new run. So what is run and what is experiment? When you are making a machine learning model to predict something, you are doing an experiment. I choose logistic regression for my experiment. In that experiment, we have this over here as a matrix, and also yeah, this values over here as a matrix. So if I change these values over here, I might get new predictions, and those prediction will be my runs. So this code right over here that you see is a new run, which can give a new output or predictions, which will be my area of analysis. So for the same experiment, you can perform 10 or 20 runs to analyze the best run, and then you will choose the best run or the best matrix over here, which is like maybe your model is performing well with the seed 24, so you will choose this one. Or maybe your model is predicting well with the seed 24 and the matrix iterator as 90 and the rec param as 0.02. Maybe. So we will choose that run. What is experiment? When we choose a machine learning model, suppose logistic regression is not good and it gives you the output as, let's say, it will take around 3 minutes. I'm sorry. So let's say it will give you the output of area under the curve, as we'll see what is area under the curve after the code gets executed. For now, assume it will give you the area under the curve as 0.7. So it is predicting 76% values correctly. But what about my remaining values, which is my remaining 24% or somewhat like that? So what I will do for those values. Suppose I create a new experiment. This time my machine learning model will be naive Bayes classifier or random forest, and in that I get my accuracy up to 98% with 13 runs, out of which one run outperformed all the runs in the naive Bayes classifier or random forest, having the accuracy as 98.5%. So now that's a different experiment with different runs and different parameters, accuracy parameters. And I will consider only those parameters which are giving me the high accuracy. So we can create such different experiments in the DataBricks itself, or we can integrate MLflow to our code. And in this video, after I run this code, we will do that. So this video is going to be a bit lengthy, but we are going to cover up MLflow as well as experiment tracking in the DataBricks itself, which will help you better understand about the real world analysis where you deal with multiple people, because over there multiple people can run the code, perform the analysis, do the experiment tracking, and it's not just you who is doing it. So your colleague is probably working on a random forest machine learning algorithm for the same dataset, and you are working on this particular algorithm, which is logistic regression. You both are performing several runs, and in the end you get to know that your colleague is getting good efficiency, so you will choose his experiment. We can automate this task as well, which is a topic of future. For now, let's just hope the model is run, and it is run. See, my accuracy is 0.7061, and then there is a big number. around 70% is not good, I would say. The area under the curve is basically this part right over here that you see. And random guessing is basically when you get the area under the curve as 50%. Since we are getting a 70, it's better, not the best. Confusion matrix states that the true negatives that it tries to predict, that means the number of values which are not fraud, the transactions which were not fraud, and it predicted those transactions correctly is 93,920. So it's a good number. For false positive, that means, what is false positive? When your label was not a fraud transaction, but it predicted it as a fraud transaction. So for that, it again gives a very fat number as 20,000. But in the case of false negative, when the transaction was indeed a fraud transaction, but it predicted it as not fraud transaction, we are only having a 77 values. And for true positive is when your transaction was a fraud transaction and our model also predicted it as a fraud transaction, we are having 111 unique values. Okay. After that, you can see the area under the curve over here. And yeah, that's it. It's not a good model, still okay-ish for the analysis, still because you are not dealing with a machine learning, I would say, understanding video. Here we are not like making the video to explain what is machine learning. We are applying the machine learning models to the real test. So it is obvious that you will not get the accuracy as 0.90 or 0.98 because this is not a data set which is set to give you that high number of accuracy. Okay. Now after that small tweak, let me just copy this code right over here and paste it over here. And the only change I will make is I will convert this particular seed into 24. And let's see what I get in the end. So these are my two runs for the same experiment, which you can name as logistic regression. So for the second run, I have only changed one value, although I can change this matrix as well, the other two matrix which I have over here. I leave it on you because I'm lazy. So now wait for some time, let it run, and then we will analyze the output. So as you can see over here, we have executed the code, and what we are looking at is the area under the curve has reduced from 70 to now 67.67. And for the false negatives and true positives also, we are getting somewhat not good values. So yeah, we will not consider this run. Maybe we can try any other run, or you can try any other run which outperforms my initial run that I did over here for the experiment logistic regression. But guys, the question is that how do we track these experiments? So that if your manager or your senior comes to you and asks you that, hey, can you tell me what was the outputs or runs for our logistic regression? I just want to check in and maybe there is something that we can do about it. So at that time you have to show him all the metrics. You can't run the code like this every time you basically want to check for it. So when you want to give the matrix, when you want to tell the person that okay, this was my analysis, this were my uh, matrix that I took for the consideration, and this was my predictions, like my confusion matrix was like this, my AUC ROC curve was like this, and this was my AUC value, area under the curve. At that time you don't show them the code, or you don't show them the files like IPYNB. You just show them the dashboard where you have all of these things saved. Greatly, we have a tool as MLflow which helps us do the same thing. Although we have DVC as well to handle this experiment tracking, but still it's a very old industry tool. MLflow is something good to use. We are going to use MLflow with DagsHub because it's a free tool, although you can use it with AWS as well. Still, the main concepts will remain the same. So now let's try to see how to implement MLflow and integrate it with our two IPYNB files and create one more experiment with a new machine learning model and analyze both the experiments and all the runs that we have in those experiments. So yeah, now let's see what experiment tracking look like. Okay, so we have two options. Either we can use a separate DagsHub application to handle the experiment tracking and to collaborate with different users, which I might leave for the future episodes because I don't want to get out too much in this video out of DataBricks, and I want to make it focused on DataBricks. And for my thumbnail also, you know, that AI generated picture, it will not look good if I add DagsBrick and everything in that. So let's keep it simple. We have the same option of using MLflow in our DataBricks, so we'll use it. Maybe it's a 1 or 20 minute step, I would say, a single step which will take 20 minutes to explain if I add DagsHub as well. So I don't know whether I will use it or not. But if you comment on this video, I will make a separate video to explain how to use DagsHub as well using this platform, which is my DataBricks, and integrate the DagsHub to it. It's a very simple step, to be honest. It's a very simple step, still important. So for now, what we can do is, this is my experiment that I created. I will destroy it because I want to create again in front of you guys. Go to the experiments right over here. Let me do create experiment. It will say name your experiment. So since we are using logistic regression, I'm going to name it as logistic regression. I'm going to run the code, and yeah, that's it. Once I do new run, it will say using notebook. It will give me this code over here. What I want to do is I want to import MLflow first, and then I want to set the experiment ID over here, and I will do autolog. So MLflow offers several features, like you can add individually the matrix of your model, you can add individually the other parameters of your model, or you have a global feature which is like a boss feature where you just have to use autolog and it will do all the things for you. It will handle everything for you. You don't have to worry about it. So what I need is I need these two things. You can this is example, guys, by the way. So you basically have to import the MLflow, and then you have to set the experiment with a unique experiment ID that you can decide. Although make sure that you don't have any other experiment with the same experiment ID, and then ML autolog will make sure that everything is auto logged in your experiment and you don't have to do it manually. This is my code right over here, but before that I have to import MLflow. So for that, what I need to do is, in my cluster, which is my Parex cluster, or in your cluster, go to this new flow and go to PyPy and install MLflow. It might take some seconds to minutes to install it. Wait for that time. I know you have to probably create multiple clusters and install this libraries in multiple cluster. Still, it is important to do it if you want to save some bucks. You can take a premium if you are a premium person and wants everything to be done fast. Okay, so yeah, it should be fine in few seconds. Wait for it. Okay, it's taking a bit longer because it's a big file library to install, not like Matplotlib, a single simple file or library, I would say. Yeah, so oh, so we named our experiment as logistic regression. In this experiment, we can run multiple runs. Okay, so going back to our code over here, since we have already run this code and my cluster is activated, it's not deactivated. So what I will do is I will simply just import first. I don't know why it's not working. Probably my. So what I will do is I first import my MLflow library, which is just like this. And then right over here, what I will do is I will set an experiment ID. This can be anything. Let's set it as one only. It's completely fine, up to you. Although industry standard says that choose a good number. I don't know who set the industry standards, but yeah, it's good for you only. Run the code part if possible. If this solves the issue, although I don't think it will. Okay, let me run this over here. Oh, my bad. Now it should work, and if not, then probably we'll figure it out. It's not going to be a difficult task. Let me run this again and wait for some split seconds to. Oh, again I get the error. Probably my cluster is terminated or something like that. No, it's not like that. It's up and running. Sometimes it's really hard to handle such errors because you don't get it when you work with the things for the first time. But eventually you get these errors and it makes everything really hard for you. But still, this is the part of development where you have to handle the errors. Nothing is like a cookbook over here. Regardless of that, let's try to run this again over here, and hopefully this time again we get the error. Okay, so it says that node 1 doesn't exist, but we can give a unique number over here which should be existing. I have given a random number over here, and it just says that it doesn't exist for this as well. uh, Genuinely I'm not able to understand what is going on, like why do I get this error. Let's copy this exact ID as well, like just to make sure that's not the case. I don't think this will be a case, but still, just a last try before I pause the recording to investigate what's the error. Oh, yeah. So this is my updated column right over here, updated experiment ID. I will run this code. It should give error. It should. Seriously, was that the error? I mean, I'm, I'm a bit disappointed, honestly. Maybe it doesn't offer you to run multiple experiments on it. That's why it's the error. It only gives you one single experiment. Maybe that can be a case. And that experiment should be with the ID as they have mentioned. If that is the case, it's wrong. I have to teach DagsHub as well because I want to show you multiple experiments with multiple runs. If there is only single experiment, then I don't think so. We will be able to understand it in a better way. Although I will show you how you can run different runs over here. While this code works, I will copy the same ID and experiment ID because I want to check for the different run. So in the code below, I will delete it first. Okay, so I got this kind of error, or I don't know what to say, but yeah. Okay, so regardless of that, if I just pass this over here, I will be getting this new run for this experiment ID, which is my named as logistic regression. I will make sure that I import my MLflow over here as well. And if this will not work, guys, don't worry. We'll use DagsHub for this. So let's just not use DataBricks for experiment tracking, although DataBricks offers it to you. So make sure that industry standards, when you go to the industry, you will not use any other platform like AWS or DagsHub for your experiment tracking. You will use DataBricks only for that. And I hope you understand what we do in experiment tracking and why it's important. So coding is just coding. You can do it in the few seconds, but understanding the intuition is important. Hopefully this code works. If not, then we'll use DagsHub to make you guys understand what we are trying to do over here. It will not take a lot of time. Still around 4 minutes will be something that it will take. Any time. You can see over here, logged run 1 on experiment in MLflow. Okay. So yeah, this is our first run over here. This will be my second run for the same experiment ID for my experiment named as logistic regression. Okay, so just some small things to keep in mind and it should work. Like that, you can also make a new machine learning model, let's say naive Bayes or random forest, and create a new experiment ID, work with the same things over there as well, with the separate runs. I should probably keep this task to you. What I can do is I can give you the code as well and a good repository with proper steps in the README file for you to perform that so that it would be something like a learning based journey for you rather than just watching the video and following the steps. So yeah, that would be great. So if this code works, what I will do is for the DagsHub integration and for the multiple runs experiments in the DagsHub, I will create a separate PDF kind of step based booklet for you, which you can follow to basically integrate the DagsHub to this code. And I will also give this code to you, so don't worry about it. It is already more than 5 minutes till it is trying to interpret. which is not a good sign, but still, now we only have hopes to handle and will handle that. So, yeah. Also, I think it will not get all the. Oh shit. I hope it continues the interpretation, although it should not. I did a very great mistake because. Oh, it is. So let's see how well it runs. I guess it is about to end the jobs. So see how PySpark divides the task into jobs. So yeah, I was talking about parallel processing. You got to see some over here. Although we don't have multiple clusters to see the true power of it. Huh. Let's wait for it to run and then we'll continue the analysis. So since we are using the experiment tracking on a very large dataset, what Autolog is doing is basically sending everything to the cloud, which is going to take a lot of time since it is going to send all the matrix, all the things that we have done. And that's why we fall in that loop. And that tracking was indeed not a correct way. Now, what I have done is greatly we got an error, but I will make sure that we solve this time. And we have to authorize it over here. Okay. I don't know whether the request was timed out or not. But yeah, with that note, let me do one thing over here. Instead of naming it as autolog, okay, so it should be not autolog. Let me first correct it. Yeah. So guys, what now we are going to do is instead of using MLflow's experiment feature in the DataBricks, we are going to use the DagsHub for that. Or probably we can use the MLflow itself, but it is not reliable now. But we will first try MLflow one last time before we move towards the other analysis that we can perform. Okay. So for that, I will go to this experiments over here. Here I see my logistic regression experiment, and this is my run name over here. And you can see this was successfully executed. And the matrix that I got was my AUC, which is area under the curve. And there were a lot of other parameters that I considered, and everything came over here. So guys, the problem is that these things are going to take time. Okay, this was the first random value that I got for this experiment. If I make video to explain the ML flow in this video itself, it will take a lot of time. But my main idea is to make you guys feel the usage of ML flow and then try to explore it on your side. Because we are not creating this video to basically analyze something. We are just creating this video to find out the best models to handle the dataset that we have. So yeah, this is looking good to me. I hope it looks good to you as well. It was created in this time. Right now you can see the time. It's 5:55. We have the created by experiment ID and other parameters right over here. So what we can do is we can again run the code for the different analysis, and it will take time for that as well. It is taking almost 20 to 30 minutes for me to run a single experiment. So yeah, I showed you how experiment looks like in DataBricks, but we will also see DagsHub. So DagsHub is a great platform to again integrate with MLflow. Here you have to basically sign in and create a new repo in which you can create a blank repo. After doing that, let me show you the interface of DagsHub. Here you will create a repo which will come like this, and you will have the instructions over here. You have to install the DagsHub, uh, which we can do easily. You just have to go to the compute and install it. I've already done it, so you will see it over here. Okay, DagsHub. That's it. Now after that, what you need to do is you need to give this to your code. So just copy paste, of course not this one, you have to copy paste your one and give it to the code. Similarly, you have to do import MLflow. You have to add this function and then you can log the metric. So earlier on you used autolog. That's why it took a lot of time. But now we are going to log the metric by our side. So we are going to set the accuracy to AUC. We are going to set the seed parameter to the value it has. So coming back to the code that I had initially, I will go over here. So when you over here on DagsHub, you can go to the MLflow UI as well. So right now you can see I can copy this part over here from this to this, and this copied path I can paste in my code. So I paste in my code. So I'll show you that as well. So once you go over here, you can see this is my URL to track. Okay, so I can set my MLflow URL over here, and this is the DagsHub credentials which I got from my DagsHub. I can copy this as well. Okay, very simple. Once you are done with these two things, you have to give the experiment name. So here I've set the experiment name as Mayank, but what I will do is I will set it as regression, sorry, log model. Okay, let's keep it simple. And then inside this mlflow.start run, I will put all other required steps for the machine learning model. Once I run this thing, I have to wait for certain time, and then I will see that experiment right over here. Although right now I have created a dummy experiment which I will delete. Okay, so you can also create an experiment from this place as well. Why? Yeah, it's deleted. So coming back to this point right over here, it will take some time. So we'll analyze it after we get the output. So as you can see, it has created an experiment over here as log model. Coming back to the code, I will again explain you the what we are trying to do in this code. We are setting up the credentials for DagsHub, and then we are setting the tracking URL, which is basically this URL. How you will get it? You just have to go to this MLflow UI. And now again make sure that this URL I can pass to anyone and they can also see this thing over here. In this URL you will see that I have this log model. Why I have this log model? Because you know guys, over here I have assigned the experiment name as log model, and then I have started my MLflow run. And in that also I have only got two parameters to save, which is my AUC and my seed. So in the metric I will only get accuracy, which is AUC, and in log params I will only get seed. If I look over here, if I go inside this code, you can see the only things that I'm getting, oh, I didn't got metric yet, which is not a good thing. I just don't know why it is making everything really hard for me, as it is keeping the experiment ID as 1. Although I have assigned the experiment ID over here, not as 1, but still it's fine. Like, it is randomly generating the experiment ID. It's fine, but still it is taking a lot of time to run. Eventually we will get the metrics over here. Right now we didn't got it because it is not updated, but we'll get the matrix over here as 0.70, which is going to be my AUC for this particular code. Either I can wait for endless number of times to show you this, or I believe you guys understood the idea or the concept behind this video. MLflow or experiment tracking indeed in itself a topic to understand, and if you want to get a starter resource like from basics, if you want to understand the MLflow and the experiment tracking, the best resource right now which I see is Vikas Das video for MLflow. He has explained it from the basic level, so even I have learned from him. So you can check out his video series. I'll make sure to put the link in the description. But I hope that you got the basic intuition around it. After letting it run for several more minutes, I will see the AUC and other details over here in the matrix param. But right now it is just going to load up for some minutes. And yeah, setting the same thing just like we did in this code right over here, my DagsHub and my experiment tracking and everything, along with my experiment name, I can do the same thing for the below code, which is having a slight tweak where I have kept the seed as 24 instead of 42, and this time what I got was accuracy of 0.67. So for this code as well, you can pass the other parameters just like we did in the above code, and you don't have to mention anything about the run. It will automatically detect it's a new run since my log params value will be changed, and it will create a new run over here. So in my log model, which is my experiment, you can see right now there is only one run. Okay, and this is my initial setup for this particular run over here, and after this whole code will be executed, which is not this one, the above one, I will get the further values. So yeah, that is it for this video. Make sure to implement the MLflow from your side, create multiple runs, or create a new machine learning model as a new experiment and try out the whole analysis over there. Try to fit the model over there and understand the difference between different models and their runs. You can also compare different runs in MLflow, which is very simple. All you need to do is click over here and do the compare. Right now you don't see this option because I don't have multiple runs. Once you get multiple runs, you just have to create on this button over here, or you can select the runs that you want to analyze instead of all runs, and then you have to click on the compare over here, and it will automatically generate the comparison to get the best run for you, okay, on basis of AUC. So yeah, hey guys, I was just about to sleep, but the code got executed, and I want to show you the output as well. You can see the code over here, and this is my MLflow UI as we saw before. If you go to the experiments over here and you click on this log experiment, log model, you will see the first experiment right over here named as melodic fox. It can be a random name, don't worry about it. Here we have the matrix as area under the curve test data, and also what matrix I have logged in using log matrix function. Okay, apart from that, here I have all other details regarding to what I have used. Okay, and I should also have my seed as 42 because I logged in that. Apart from that, we have the model metrics as this. We have the artifacts over here, which is my whole code, and this was the reason it was not working really fast because uploading all this data online is not easy. Like you are going to upload this to cloud, it will take some time. So that's why it took some time to run, but yeah, it is updated successfully. If I do the same changes which I did in this code to the below code where the seed is different, it will create a new run. So do that on your side, and then what you need to do in the end is basically in this particular model, select both the runs and try to compare, and it will tell you which is the best run that you should consider. And then after that, doing that, create a new experiment, not here in the code itself, in the DataBricks, and set up everything, but now with the experiment name as random forest or naive Bayes classifier. And over there also apply several runs and analyze which is the best experiment and the best run for you. So yeah, so I couldn't resist myself to show you the last update. So what I did was I executed the same code over here, which I did above, but instead of keeping the seed as 42, I kept it as 24. Coming to the MLflow, over here you can see I have this log model. Now in this I have two experiments. Very first thing that I want to do is I want to check on my second experiment, which was named as carefree mouse. It just gives a random name. Over here I get my accuracy as 0.6812, which is correct. My seed as 24, which is again correct. Now what I want to do is I want to compare both these models. So just go to the compare, and you can see after doing it I will get something like this, and it says that for the seed 42 I get the highest accuracy, and similarly for the seed 24 I get the accuracy as somewhat over here, which is low. Okay, so again these are all the metrics that we have. We can have the scatter plot as well to understand the difference. Although right now we only have two runs, you need around 13 to 14 runs to at least see something. These are the box plots that we have. We can keep anything to create a box plot. We can create a seed and the accuracy over here to the box plot. So for the 24 you can see the accuracy is lower, and for the 42 it's higher. So like that you can analyze it. It's simple. So once you get a lot of runs, once you get a lot of parameters of matrix and of matrix parameters and general parameters that you give to the model to get those matrix, you will understand how you use this plots and scatter plot and general analysis over here. So yeah, that was everything for this video. That is it for this video. We saw about DagsHub, we saw about DataBricks, how to integrate the DataBricks to the data, how to analyze the data, how to use MLflow, why to use MLflow, and everything like that. So yeah, that's it for this video. Have a nice day. In the next video, we're probably going to make a Streamlit application or a Flask application to basically answer the queries of the business analyst in my bank related to anything about my dataset.